Then come to here. Coming to waves. YouTube already given, Nana. Waves here. Yeah. So in the waves chapter here, second year, right? It is bit linked to oscillations chapter. So try to recollect something from there. Waves means, particularly, first of all, what we say. What is meant by wave? Okay, wave is nothing but is simple disturbance disturbance produced maybe there, I think, produced in a medium. Okay, whatever the disturbance produced in a medium, that is called as wave now. Okay, and in that wave, okay, we can represent in different forms what you learned in lower standards. Okay, but fundamentally here he is saying further disturbance to propagate from one place to another place. Means disturbance means a clap. Suppose you produced here. Clap produces some sound. Okay, suppose your friends stay there and he is able to hear the clap sound produced by you. Then we say, yes, that clap sound produces some disturbance in the medium. That medium carries the disturbance to your friend and giving some sensation of hearing, sensation to ear. He is able to hear. Am I right? So the disturbance to propagate from one medium to, in the medium from one place to another place, okay, means from here to there to propagate after producing the disturbance, after producing the wave, okay, that for the propagation, whether it requires a medium or not. Okay, if it requires a medium for the propagation, then that is called as one kind of wave. If it does not require a material medium, that is called another kind of wave. Means basically waves we are distinguishing into two types. Okay, once again I am repeating, whatever the disturbance you produced, suppose that propagates in a medium, okay, from one place to another place, that is called as wave. For the propagation, if it requires a medium, if it does not require a medium, then what are they? I am writing here. Okay, so first, you understood the definition of wave, Nana? First of all, yes, it is just a disturbance, okay, produced in a medium. Okay, right, good, right, thank you. Then for the propagation from one place to another place, one place to another place, Means from one point to another point. Better we write point here. From one point to another point. Okay. The wave. Okay. Or simply we write like this. If the wave requires the help of, means requires a material medium. Okay, requires the help of a medium. Medium means what, sir? Don't ask. It may be a solid like wall. It may be a liquid like an ocean. It may be a gas. Okay, like here the air. Anyone is called as material medium. So for the propagation, if the wave requires a material medium, then it is called, means the wave is called mechanical wave. Okay, so the wave is called as mechanical wave. Okay, here this is the wave. Sir, if for the propagation from one place to another place, whatever the disturbance created does not require a material medium, sir. Okay, for the propagation, if the wave does not require a material medium, then it is called as, do you know its name? Anyone? Do you know the name of it? Which does not require a material medium. Not light waves. They are called as electromagnetic waves. Okay. Light wave is an example for the electromagnetic wave. Okay. Who sent this? Saket. Saket. You said a light wave. Light wave is nothing but electromagnetic. It means it is the example for electromagnetic wave. So here I write your answer. Example, light wave. Which require a material medium, that is called as mechanical wave. Here I write the example. This is sound wave. Yeah, sound wave. Sound wave requires material medium. Light waves won't require a material medium. That's why they are called as electromagnetic waves. These are called as mechanical waves. Okay. And then here Sharma asked, sir, here when the wave is propagating, actually what passes in the waves? So you said that wave produced at one point. Suppose you turn down the TV, one beautiful song played there in the TV, and yeah. What, Lakshmi Gayatri? Will we also wave is a mechanical or electromagnetic? Will we also learn why a wave is mechanical? Yeah, wave is a mechanical wave when it requires a material medium for the propagation. Wave is called as electromagnetic wave. Why? If it does not require a material medium, that is called as electromagnetic wave. That's why we are distinguishing who are dependent, who are independent. Okay. All of you are, I say, mechanical waves. Why? Because all of you are taking the help of lecturers. You require a material medium. So all of you are mechanical waves. Okay, few students, they learn by their own without listening the classes. Okay, like the intelligent students, Babu Bangaram, like such type of students. Okay, they learn by their own. Such type of waves, not Amog. He is innocent boy, Papa. Don't involve Amog, Mr. Sharma. Okay, Mani Babu. Hey, Ishan is a good boy. Amog is innocent boy. Yeah. Okay, right. Then here, he is electromagnetic wave. Okay. Right. Okay, right. Then coming to here. So best example. Okay, we are all mechanical waves. Such type of students are electromagnetic waves. Okay, and Sharma asked here, sir, really in the wave, what is actually propagated? Means from one place to another place. Okay, that one, what I am saying, wave is propagating from one place to another place. Wave means some disturbance. Okay, it carries the energy from one place to another place. Okay, Sharma. So wave carries what? Energy. Okay, from one place to another place, from one point to another point. Thank you. Another point. Okay, problem is when this energy is carried by the wave from one point to another point, it is not independent in the mechanical wave. It is dependent, taking the help of a medium. That's why here, while carrying that energy, the medium to propagate the energy from one place to another place, energy, the medium also absorbs some amount of energy. Okay, once again I am repeating here. Suppose energy is produced, wave is produced, here some disturbance is produced. It is propagating in the medium from here to there. Through whom, sir? Suppose air. Oh, it is taking the help of air, sir? Yes. It is taking the help of air means it is a mechanical wave, surely. Why? Because it is taking the help. Okay, moving from A to B. Okay, wave is moving, carrying the energy just by holding a bag. Okay, and carrying here to there. Problem is, while carrying, it is taking the help of air. That's why air also absorbs some part of energy here from the wave. That's why whatever the amount of energy created here will not reach to the point B. Means here, suppose if I create 100 joules of energy, while carrying from here to there, who is carrying? Wave. While carrying, taking the help of air. So to propagate, air is absorbing some amount of energy from the wave packet, means from the wave energy is absorbed, and here when it comes to there, it may be reduced to like 40 joules or 30 joules, not like resistance. It is taking the help. So air takes some amount of energy from it and helps it. Who here, suppose if you want oxygen cylinder, they won't provide the oxygen cylinder to you not directly. You have to pay something. Then only they provide the oxygen cylinder. Means there you shall, whatever the amount you have in your pocket, that you have to give to the medium. Then they provide the oxygen cylinder to you in this pandemic period. Am I right? This is what I said, dependence. If you depend on others, this is the problem. Okay, right. So in the mechanical wave, always said thank you. In the mechanical wave, major disadvantage is while carrying that energy by the wave from one point to another point, surely there will be some loss of energy in the medium. Okay, that's what I write here. In the medium, when the wave is propagating, there will be some loss of energy. Okay, so total energy is not carried to the other end. This is what they are saying. Okay, so surely there will be some loss of energy. That's why here, even in the classroom also, suppose we are lecturing the class, how loudly the first bench student hears, that much loudly the back bench student may not hear. Why? Because whatever the lecture produced by the master, that is propagating through air. So while going from here to there, some loss of energy in the medium. So the backbench student, when the sound reaches to the backbench student, there will be some loss of energy. So he may not hear that much loudly. So you understood, and you, I think, observed this in your classroom. Am I right? Is it correct? Yeah. That's why who wants to listen the class carefully and keenly, though they want to sit in the first benches only, not in the back benches. Yes, yes. To hear the clear loudness and sound. Okay, right. This is the story. Okay. In this chapter, what you are going to discuss in the waves part, sir? In this chapter, I discuss only mechanical waves now. Electromagnetic waves, we have a separate chapter. There we will discuss, no problem. That's why here we come to which part? Mechanical waves. Okay. So come to here, mechanical waves. So first of all, here when the mechanical wave is propagating in a medium, what happens in the medium? If you observe, this disturbance, whatever you created here, while propagating in the medium, okay, it gives some amount of energy to the medium particles and tries to oscillate those medium particles. When they are oscillating, then the energy is carried to the other points. Okay, once again I am repeating, in the mechanical wave, okay, it is taking the help of the medium. How it is taking the help? It gives some amount of energy to the medium from its back. It gives some amount of energy. By absorbing that energy, the medium particles either vibrate like this or like this. Okay, vibrate and transfers the energy from one place to another place. So basically, if you think how the wave propagates, the wave is propagating, particularly mechanical wave is propagating means by the vibration of medium particles only. Keep in mind. So shall I write that point here? Maybe not. That I don't know. Depending upon, maybe up and down. That's what I'm saying. Or like horizontally or vertically. Right? Okay. First mechanical wave here. The wave is propagated . by the vibration of medium particles. When the medium particles are vibrating, then only energy is carried from one place to another place. That's why it is purely linked to oscillations chapter. That's what I said. Okay, vibration, oscillations, that is related to oscillations chapter. So first of all, we try to recollect few things from oscillations which are required here. Okay, what you require, sir, you ask, just like that we say the answers, sir. Okay, I have a lot of confidence on you all. Why? Because Amols are touched. Okay, not CHAKRI, sir. So I think all of you are thorough with the oscillations. So shall I start here? Shall I ask few questions? Whatever required for my chapter. Yes, sir. Okay, thank you. Here, first one, what I'm asking, that is the second point in the mechanical wave. When the medium particles are oscillating, okay, when the medium particles, okay, ask it, yeah, wait, when the medium particles are oscillating, then I write here, what, sir? How you represent the displacement of medium particle? Then the displacement of medium particle. Y equals to, I think all of you know it. I think Sir said like A sine omega t plus or minus phi. Am I right? Yes. Or A y equals to A cos, either sine or cos. Yeah. Yes, yes, very good. Omega t plus or minus phi. This is the displacement of medium particle. Yeah, thank you, thank you. Okay. And number two, the velocity. Its velocity. V is equals to, I think all of you remember, A omega into cos omega t plus or minus phi, or V is equals to, if I differentiate this one, which is dy by dt, is equals to A omega sine omega t plus or minus phi. That is, of course, minus. Okay, magnitude I write here better. So no negative sign. A omega sine omega t plus or minus phi. Is it correct, Nana? Yes. And the same one by interlating the velocity and the displacement. V is equals to, shall I write, omega into root of a square minus y square? I think you know this formula also. Am I right? Yeah. Okay. Here the maximum velocity of medium particle I can write here. Anyone remember maximum? V max. What is the formula for V max? 1 minute. That is simple only. A omega. Okay, right, no problem. It is a running chapter now, forgotten. Okay, right. V max is equals to A omega. Right, this is the maximum velocity. Sir, all they are required, sir? Yes, required to interrelate with something. Okay, A is the amplitude. All of you remember? A is the amplitude. Amplitude means, remember what is the definition? Yes, maximum displacement on either side of mean position. The maximum displacement on either side. Okay, right. Yeah, on either side of mean position, right. And here if you come to the acceleration, it's acceleration. A is equals to, I think all of you remembered, by differentiating this one more time, you will get minus A omega square sine omega t plus or minus phi, or minus A omega square cos omega t plus or minus phi. And or you can write A is equals to, by interlating with the displacement, minus omega square y. Remember this one, Nana? Yes. And next one is, what is the maximum acceleration? A max. That is minus omega square A. Okay. These are the points what you recollected, whatever I wrote here in green color, recollected from Amol Sir's class. Okay, that is from oscillations. So any doubt here from the recollection? And any formula I wrote wrong? All are correct, I think. Yeah, thank you. Okay. Now, when you come to wave, yes. Okay, that too particularly mechanical wave. You said here, from this, mechanical wave propagates when the medium particles oscillate. Okay. Sir, oscillating. I have some doubts, sir. What's your doubt, Nana? Suppose wave is propagating along x-axis, sir. Okay, good. Means the disturbance is moving in this direction. Yes, sir. When the wave is propagating in the medium in this direction, sir, how the medium particles vibrate, sir? It is a simple question, Nana. How, sir? The medium particles may vibrate along y-axis. Oh, sir, perpendicular, sir. You only say, yes, sir. That is along x-axis, sir. Whereas this violet color is along y-axis, sir. Okay, perpendicular to the propagation. Or along z-axis. Z-axis I can't represent here in the on the board. So I just put a dot here along z-axis, or may propagate like this. Oh, propagate, vibrate like this means what, sir, you are saying? Vibrating parallel to the propagation of the wave. So once again I am repeating, it is the propagation of the wave when the wave is particularly mechanical wave, but mechanical wave is propagating in a medium. Okay, then this is in a medium whereas this 1, 2, 3, these are the possible ways of vibration of medium particles. Okay, 1, 2 and 3 are the possible ways of propagation, possible ways of vibration of medium particles. So medium particles are vibrating how? That you have to check. Look at 1 and 2, both are perpendicular to the propagation along y-axis and along z-axis. Am I right? Both 1 and 2 perpendicular to the propagation. Is it correct? Yes. Whereas the third case you observe, it is parallel to the propagation or perpendicular to the propagation. Parallel or perpendicular? Third one. Parallel. So while classifying this mechanical wave, you can classify in two ways. Yeah, during the propagation, how the medium particles are vibrating. Perpendicular or parallel. Perpendicular, distinguish. That is one kind of wave. Parallel, distinguish. That is another kind of wave. Okay, so here I am classifying mechanical waves. Keenly observe, waves basically we classified into two types, mech and EM. Electromagnetic waves, mechanical waves. Okay, and then here again mech or they were classified into two types, how the medium particles are vibrating. This part I am writing here. Okay, so mechanical waves here, they are classified into two types. One is medium particles are vibrating perpendicular to the propagation. That is called as transverse wave. This one I think you know in your lower standards. And here parallel, this is called as longitudinal. So classifying into two types. This is known thing in your lower standard. I think 10th class, exactly, you are right. Okay, maybe in 10th class. Okay, right. In these transverse waves, here I am writing the medium particles vibrate perpendicular to the propagation of wave. Whereas here I write the medium particles. Yeah, vibrate. Manikanta, you are intelligent, so you are on that too electromagnetic wave master. Why you are asking the question? You are independent. So you only identify the medium particles vibrate parallel to the to the propagation of wave. Okay, matter waves are different now. They will come in dual nature. Okay, right. So basically we have again here mechanical waves two types, transverse and longitudinal. Okay, either transverse or longitudinal wave, actually how you represent when you come to mathematical. Okay. That one here he is saying mathematical representation. We are coming to here, representation of a wave. Of a wave. See, of a wave. Okay. Keep in mind, I did not mention here longitudinal wave or transverse wave or mechanical wave or electromagnetic wave. Any wave can be represented mathematically like this. Okay, when wave is propagating, suppose if I draw, this is y-axis and this is x-axis. Okay, and the wave is propagating along the x-axis, the two towards x-axis, like this. Wave is propagating. Okay, when a wave is propagating along positive x-axis, then at an instant, means after a time t, here what will be the displacement of the wave? Okay, that not medium particle, no. Displacement of medium particle, here already I said y is equals to a sin omega t plus or minus phi. And keep in mind, medium particle is in oscillatory motion. Oscillatory motion means one particle, suppose existing in a medium, there only it vibrates along or like this. Okay, means this medium particle is not going to some other place from A to B. Okay, right? So that medium particle is vibrating and giving the energies to some other medium particle. Again, it comes into vibration either like this or like this and gives the energy to some other medium particle. So disturbance is moving along the x-axis, but the medium particles are vibrating there only. Now you understood that difference, Nana? Medium particles are not going from A to B, but the disturbance is going from A to B by the vibration of medium particles. Is it clear? Right. So here, when you come to the displacement of wave, thank you, displacement of wave, I have to involve the x term also. Simple. Because here when the disturbance means wave means energy is propagating in a medium from one place to another place, energy is moving along x-axis, but medium particles are vibrating there only. Okay, suppose best example I think you can understand. Sharat sir said, Nana, today no worker came to the college, Nana, no office boys are there. And here you got your material, college material. Here simple, all of you stand on the steps, one above the, means one beside the other. And when you carry all the books to the top floor, means top floor, ask, immediately all of you stand on the steps. Okay, first person gives one book to you. You give the book to another person. The other person give the book to the another person. Likewise, book is carried to the top floor. But you stood there only. Now you understood my example? Ambika? Social distance, of course, maintaining. With masks, that too. Yeah. Right? Maintaining the social distance with mask. Yeah. Means you stood there only. But a book went to the top floor. Simply you are giving to another person, that person gives to the another person, like. Okay, right. Here book is the energy, you are the medium particle. Of course, after sanitizing. Okay, wave is moving, but you are not moving, Manibabu. Try to understand. Wave means energy. Energy is moving, means book is moving. You are not moving. You are the medium particle. Suppose office boy comes to the college, then all of you go and sit in the classrooms. Only office boy carries the book, putting those luggage, that luggage over his head, and he only carries, stepping up and carries to the top floor. Understood the difference? Yeah, this is what I'm saying. Yeah, so medium particles are moving not from here to there like you. Okay, but the book is given from one person to the another person, means energy is carried from one to the other and reaches to the other point. Okay, this one what I say. So energy has x displacement. Okay, means along x-axis, whereas medium particles are vibrating there only. They are not having the displacement along x-axis. They are having the displacement only with respect to time. That's why here, while saying the displacement, okay, along the positive axis at an instant after time t, the displacement of wave, not medium particle. Okay, since it is having the displacement along x-axis, also I have to write y as a function of time and displacement. Okay, function of t comma x, right? How you write that as a function of t and x are simple to understand, very simple. You see here, while writing something, both must possess the same dimensional formula. That's why to get the same dimensional formula of x, time, it can be written as v into t. Velocity into time gives what? Displacement only. Is it correct? That's right. As a function of time and x means I write vt and x. Both have same dimensional formula. Okay. And while writing here, first of all, I say whether it is moving along positive x-axis or negative x-axis. Once you check over here, it is positive x-axis. Then you put here minus. That's it. I think you understood. If I ask, it is moving along negative x-axis. Minus of minus, that becomes plus x, correct? Similarly, along negative x-axis, shall I write y is equals to function of v into t plus x? Will you accept? Right, good. So this is along y-axis, positive x-axis, and this is along the negative x-axis. Yeah, correct. These are the two equations what you have to remember while moving positive x along positive x-axis, while moving along along negative x-axis. Look at that. Okay. Basically, the wave is represented with the function of sine or cos. Okay. That's why in trigonometry, when you come to trigonometry, I write these two equations like, okay, how sir? Right. In with the trigonometric functions, not trie functions, trigonometric. Okay, right. With the trigonometric functions, I write y is equals to that function. I write sine vt plus x. Okay, displacement, maximum displacement I have to say as amplitude. So a sine vt plus x. Sir, usually sine, this should be angle, sir, in sine function. Angle means this should be omega into t, sir. Instead of omega, you wrote v, sir. I think it is wrong, sir. No, not like that. Oh, you want the angle here like omega t, na? Yes, sir. Okay, so omega t. Shall I write? Do you know this formula in your lower standards? V is equals to nu lambda, where nu is the frequency and lambda is the wavelength. I think you got this in 10th class. Am I right? Yeah. V is equals to nu lambda. And in your oscillations chapter, omega is equals to 2 pi by t, or that is equals to 2 pi nu. Anyone remember? Yes. Okay. Then in place of nu, yeah. Here I no. Ayo, t is equals to 2 pi by omega in oscillations chapter, time period. Ishan. Amma, just almost 1 minute. Yes, sir, correct. T is equals to 2 pi by omega. Okay. Time period is equals to 1 by nu, reciprocal of frequency. Then cross multiplication. Omega into 1 is equals to 2 pi nu. Correct only? No. Able to recollect? Good. Okay. So omega is equals to, by taking the cross multiplication, 2 pi nu. Good. Sir, why you are taking all these formulas, sir? Simple. You only said it should not be Vt, it should be omega t. Na? That's why trying to replace V with omega. Okay. So here, if I write V is equals to nu lambda as V is equals to nu is equals to omega by 2 pi into lambda. Okay. Oh, to get here omega, I have to write lambda by 2 pi into V. Now you understood, Nana, this step? Sir, what you are saying, sir? Not even a single step we understood, sir. Understood clearly? Sure? Yeah. So to get omega here, I understood I have to multiply this V with lambda by 2 pi. That's why to bring the omega multiplied with lambda by 2 pi. Now, with all corrections, finally I wrote. Yeah, this is along the positive x and this is along negative x axis now. Okay, so better I write here. This is plus or minus. Yeah, 2 pi. Lambda by 2 pi or 2 pi by lambda? Which is correct, Nana? V into lambda by 2 pi is omega, na? Arey, lambda by 2 pi, gadra? V into lambda by 2. Is it 2 pi by lambda? Anywhere I did the mistake? What is this? I only confused. Oh, I only confused. Sorry. It's my mistake. Thank you, master. Sorry, Sharma. Sorry, Ra. Okay. Omega is equals to V into 2 pi by lambda. Sorry. Right. Here 2 pi by lambda. Now is it correct, Nana? Hammaya. Thank you, Isha. Thank you. So finally the equation is corrected with all dimensions. Okay. Now dimensionally this equation is correct representation of a wave. Y is equals to a sine 2 pi by lambda into Vt, either plus or minus. Oh, Sharma, sorry. Sometimes it happens, not the eighth wonder. Okay, right. It happens sometimes. After a long time, I'm taking the class for you all. Yeah, a little bit panic. Why? Because all of you are Indian, intelligent students. I'm teaching to intelligent students after a long time with a break. Thank you, Isha. Right. Okay, finally coming to here. That implies displacement of wave. Finally, I'm writing here. Y is equals to a sine, finally what I got, 2 pi by lambda into Vt, either plus or minus x. Okay. This equation, when you come to numericals, you may get sine or cos nana. That's why don't ask again in exam. Okay. It may be better I write or. Y equals to a cos 2 pi by lambda into Vt plus or minus x. This is the representation of wave with the trigonometric functions. Okay, any wave, either electromagnetic wave or mechanical wave, any wave you can represent like this. Okay, right. But here today we are discussing, not today, in this chapter we discuss only the mechanical waves. Okay. So better we say it is the representation of a mechanical wave. Okay, any wave that is either longitudinal wave or transverse wave, it is representation of mechanical wave. Okay, when you come to numericals, this one we write in different ways now. Okay, how sir? Here the different forms of a mechanical wave. Okay, is the different forms. The different forms are, what are the different forms? Number one, direct this one already you know. Y is equals to, sir, how many times you repeat, sir? Just one by one I am writing here. Vt, suppose I take minus or plus or minus, that is your wish. Okay. Number two, here if I take 2 pi by lambda into the bracket, how much you get there? 2 pi by lambda into V is, already I said here, omega. 2 pi by lambda into V is omega. Is it correct, Nana? Okay, from this box. Yes, from this box. Right? Coming to there, after multiplying, here I will get 2 pi by lambda into V is omega into T plus or minus 2 pi by lambda into X. Okay. This 2 pi by lambda, what you took here in multiplication of X, called as propagation constant, where 2 pi by lambda is equals to K, called as propagation constant. Or from chemistry, 1 by lambda is called as wave number, na? Or else it is called as wave number. While saying that 1 by lambda is equals to r into 1 by n1 square minus 1 by n2 square. Atomic chemistry. Rydberg's constant. This is called as newborn, which is called as wave number. Okay. Yes. So that wave, you may call it as even wave number also, reciprocal of constant wavelength. Okay, right. Very good. So here, this is the second one or second one. I write here. Okay, take it as second one. Okay, third one I write here. Y equals to a sine omega t plus or minus this wave number, which is k, I substitute here. That is kx. Okay, this one very frequently in theory we use. So frequently used equation is a sine omega t plus or minus kx. This one we use from tomorrow onwards, frequently in the class. Okay, right. So shall I stop here and I will continue the class tomorrow? Okay, Nana. Yeah, thank you. Okay, right. Bye everyone, Nana. Yeah.